Okay, AP Stats fans, our topic for today, this is section 10-1. This is our second day of this topic, and we're going to talk about doing a confidence interval for two proportions. So before we begin, let me give you your joke of the day. Why was the cook arrested? He was caught beating an egg. All right, so here's the problem that we're going to look at, and I got this from the StatsMedic website. A recent random sample of 200 US females revealed 110 used Twitter regularly. A separate random sample of 150 males revealed that 60 used Twitter regularly. Construct a 95% confidence interval for the true difference in proportions who use Twitter regularly. So we're going to do females minus males. So we're going to try to calculate what is the true difference of proportions. That's our goal right there. So we're going to use a 95% confidence interval to do that. Now the idea when we use confidence intervals, we're going to use the acronym PANIC, where we state the parameters, the assumptions, our conditions. We name the interval, we find the interval, and then we make a conclusion about the interval. So that's our strategy here. So let's go ahead and start with the parameter, and in this case, the parameter is going to be p sub 1 minus p sub 2. So where p sub 1 is the true proportion of females, so we're going to say that this p1 minus p2 is the true difference in proportions. So the true difference in proportions, females minus males, of Twitter users. Or we could say regular, people who use this regularly for that. Okay, so that's going to be our parameter. Now, in this case, they've given us some information. We do know that we had random sample. We had 200 US females. That's going to be our sample size, N1. And then 110 is the number who use Twitter regularly. So we can say that our sample size, our sample proportion is 110 divided by 200, which is 0.55. And then for the males, we had 150 of them. 60 of them use Twitter regularly. So the sample proportion of males that use Twitter regularly is 60 divided by 150, which is 0.4. Okay, so these are going to be our two sample proportions here and here. All right, so we named our parameters. Okay, there's the P. The next thing we need to do is check the conditions, which is the assumptions. So for us to do this, we need to have a random sample. And they tell us that we have a random sample for the females, and we have a separate random sample for the males. So the random condition is good. The independence condition, which is going to be the 10%, we can say that 200 is less than or equal to 10% of all US females. And in the same way, we can say that 150 is less than or equal to 10% of all US males. That is a safe assumption for us to make. So the 10% rule is good. And the last one is the normal condition. Because this is proportions, we'll use the large counts condition. And the large counts, we test n times p, which has to be greater than or equal to 10. So for the females, that would be 200 times their sample proportion, which was 0.55. And what we get there, we get 110, which actually they already told us that. and that is greater than or equal to 10. And then we also have to test that n times 1 minus p is greater than or equal to 10. But in this case, if 110 of the females use Twitter regularly, and this is out of 200, then we know that 90 would be the ones who don't use Twitter regularly. So that would be n times 1 minus p. So it works for the females, that's good. Now we also have to use the males. We know that there's 150 males, 60 of them use Twitter. Well, if we do n times p, if we do the sample size, which is 150, and we found that their proportion was 0.4, well, that's where we're going to get the number 60 from. 1 minus 0.4 is 0.6, and that's going to be 90. 60 plus 90 is the 150. Both of those are greater than or equal to 10. So we've got the normal condition. All right, so we can use a normal approximation. So there's our large counts right there. So all of our assumptions, our conditions are good. So we're going to name this interval, and the kind of interval we're going to do is a 2-sample Z interval. When we are talking about proportions, it's always going to be a Z interval. For that, if we're talking about means, usually it will be a T interval, although it is possible that we could use Z if we know the true standard deviation for the populations. So we're going to do a 2-sample Z interval for our difference in proportions for P1 minus P2. Now, just as a review here, the general formula for a confidence interval is we take the point estimate plus or minus the margin of error. So the point estimate is kind of our starting value, and then we are going to subtract a certain value to the left, we're going to add a certain value to the right, and that's going to give us our interval of where we think the true proportion is going to be. Now, back in chapter 8, when we were talking about confidence intervals, we would take the point estimate and we would take the sample proportion plus or minus the Z critical value times the square root of P times 1 minus P divided by N. Okay, and that's the sample proportion that we were using for that. Okay, this was the standard error, and then when we multiply that by the Z critical value, that gives us our, this is the margin of error, and then this gives us the interval. Now, in this case, because we have two proportions, we have a difference of proportions. So now what we're going to do, the point estimate is not just sample proportion because we have two of them. So it's going to be the first sample proportion, which will be for females, minus the sample proportion P2, which is for the males. That's our point estimate, plus or minus the Z critical value times the square root. Now this time, remember, we have two proportions, so we're going to take the sample proportion for the females times 1 minus their sample proportion divided by N plus P hat sub 2 times 1 minus P hat sub 2 divided by, now this is N sub 2, this was N sub 1. Okay, so we're doing the same formula, it's just instead of one proportion, now we have two proportions for this. Okay, so P hat 1 minus P hat 2, well, we know what those are. For the females, that was 0.55. Subtract the proportion of males who regularly use Twitter in our sample was 0.4 or 0.40, plus or minus. Now the Z critical value, we're doing a 95% confidence interval. Now on my calculator, I'm going to come over here. If I look at a normal curve, so we want this needs to be 95%, which means that for the tails to the left and the right, that's the other 5%. So that's going to be 0.025 and 0.025. So the thing with my calculator, when I do normal, when I do an inverse norm, it's going to tell me all of this right here. So actually what I have to calculate is for 0.975. So I'm going to take the calculator, I'm going to do an inverse norm, where the area is 0.975, the mean is 0, standard deviation 1, and we get 1.96. 1.96 is the z critical value, times the square root. And all right, so the sample proportion for females was 0.55. 1 minus that is 0.45, and there were 200 females. And then for the males, it was 0.4. 1 minus that is 0.6, and there were 150 males. And now this is a calculator problem. So let's see, 0.55 minus 0.4, we can say that that's 0.15. And then I'll subtract the square root. I'm going to make a fraction here. Hold on. Before I do that, let me put the z critical value, 1.96. Now times the square root. And we'll do the fraction. So 0.55 times 0.45 divided by 200. Plus another fraction. We'll do 0.4 times 0.6 divided by 150. And I need to be really careful here because there's a lot of values that I'm typing. So I get 0.046. If I round it to 3 places here, so 0.046 is the left bound of my interval. And then for the right bound, I'm going to use the same values, except instead of subtracting the standard error, now I need to, or instead of subtracting, this is the margin of error. Now I need to add it. And we get 0.254. So 0.254. If I want to go to 4 places, I would go 0.04, I'll change it to 4 places, 0.0456, and this would be 0.2544. Okay, if I want to be more accurate. All right, so we've done parameters, assumptions, we named the interval, we've calculated the interval, and one other thing before we make the conclusion. We're getting to the point here, you don't need to do this on the test, on the AP exam. This is taking a lot of time for you, and time is very crucial. I would use the calculator for this, and if we go stat tests, and on the TI, I need to do a 2 proportion z interval. 2 proportion z interval. I would type in my values, females for x sub 1, n sub 1, and then the males, confidence level is 95%. Calculate, and there it is, 0.0456, comma, 0.2544. Okay, so save yourself the time. The last thing that we do here is we're going to make the conclusion. And in this case, we can say we are 95% confident that the interval from 0.0456, here I'll use the word from 0.0456 to 0.2544 captures the true difference in proportions. The true difference in proportions of females to males who use Twitter regularly. Now, one thing that we can also comment on here to finish up this video, notice that the interval does not contain 0. Now, we subtracted the proportion of females minus the proportion of males, and we're ending up with positive values here. So what that tells us is that most likely the true proportion is going to be a positive value, which means that typically females are using Twitter more regularly than males are. If both of these were negative values, if P sub 1, if the sample proportions, if we subtracted those and we had negative values, that would tell us that we think that males use Twitter more regularly. If we end up with a negative and a positive, where 0 is part of the interval, where there's really no difference between the regular use of females and males, then we're not going to be able to make much of a conclusion. Okay, so that is the end of part 1. Now we'll go to part 2 and we'll do a significance test.